Advantages of a natural swimming pond in your own garden. Why build a dreamlike swimming pond? There are endless reasons to build a natural swimming pond. For example, economic reasons. It is about the upgrading of a property in valuable city locations. Land near the city or in the city is expensive. Instead of building parking spaces on your own land, we should increase the residential value by enhancing the nature of the garden by making optimum use of the usable space. Luxury reasons. In troubled times, in strenuous jobs, or simply for reasons of deep relaxation, we would like to see a natural oasis that doesn't smell like a chlorinated swimming pool, but with a smooth transition to the garden, or for optical reasons in the immediate vicinity of the house. In combination with the sauna, the use of the swimming pond, which is often limited to 5 months in Europe, can be extended by another 2 months by use as a cooling bath. Ecological reasons. We can encounter a natural elimination with closeness to nature. Biodiversity is increasing dramatically and we can observe a large number of flora and fauna. We have an observation area right in front of our window. We take more time to observe complex ecological relationships. We are suddenly breeders of tropical or native water lilies. We get to know many dragonfly species and see how they hatch. We understand the cleaning function of reed species and underwater plants better. Technical reasons. Creating something big, expensive and new yourself and to bring in pond professionals when necessary is simply wonderful. Every pond self-builder or anyone who has built a swimming pond by professional help is proud in the end, because a lot of work has been done and we have become immensely richer in experience and perhaps awe for nature. The following questions of a technical nature need to be answered. How should the water quality be permanent afterwards? If we accept nature as it is, we accept the green water color. The reason for this is a numerous algae species which are the first to populate our pond as fast settlers. Crystal clear water is what is possible all year round under slightly higher effort. We get to know and classify pH and pH, also pH-Wert and Kalkhärte, phosphorus and nitrogen values through water analysis. Building physiology of natural swimming pond. Construction situation in Germany. Swimming ponds are often built in Germany on a small garden area of the city gardens. Water depths have a legal meaning. In Germany, the burden of proof is reversed from a water depth of 1.35 meters. That means you have done everything possible to keep damage away from other persons. From 2-meter water depths and from 100 cubic meters water volume, a building permit is required depending on the location. This leads to smaller water basins. However, these should not be less than 50 cubic meters total pond volume for reasons of stability of the installed ecosystem. Is permanently crystal clear, slightly greenish water possible without chemistry? Yes. However, with such high demands, the effort on filter technology quickly increases by several thousand euros in the one-time acquisition costs. Foil or garden pond made of natural materials or GRP basins? Another question. In the case of natural ponds made of clay soil, A high possibility of 100% water loss could occur in dry seasons, because clay forms cracks in dry conditions. This is why foil ponds are common today. Concrete armor of the foil. Each film is more or less UV stable. This means that with good foils you lose and tear plasticizers due to the aggressive sunlight after 30,000 hours of sunshine. Now we can take a 1.5 mm thick film instead of a 1 mm thick one. However, we should protect each basin from frost ice cracks, animal claws, for example urban raccoons, and the UV irradiation already mentioned. This 3 up to 5 cm thick concrete tank is slurred with a composite mat, a multi-fiber support mat, and then cures to form a stable pond shell. Fleece against root damage under the foil. Another protection is a common dense fleece, which is much denser than the usual weed protection mat in the garden, which is laid under the soil. Avoid film breakthroughs. Any breakthrough of a pond foil is a safety risk and leads to high follow-up costs, not only by finding a hole and closing it. If a concrete armor of the film is provided, any underwater technique can later be incorporated into the concrete layer invisibly. These can be low voltage hot headlights or sediment traps, for example modern floor drains and their suction lines. Complicated film breakthroughs, if at all, should only be practiced by the experienced expert. Nowadays, GAP basins can be ordered up to 20,000 liters as rectangular basins in the do-it-yourself store, but are more suitable for conventional garden swimming pools due to their smooth vertical walls. GAP basins are more expensive than foil because aesthetically necessary foundation is normal concrete formwork stones and expensive two-component resins have to be used. For small pools and for waterfalls, however, they are excellently suited and extremely weatherproof, free of tension cracks. Different versions of swimming ponds. Either we build ponds with large water depths of 2.5 or 3.5 meters and large volumes where the nutrients accumulate at the bottom of the pond and are not stirred up by swimmers. These are extracted 2 or 3 times a year with a dirty water pump. Furthermore, we need a separate pond edge with aquatic plants or an extra plant filter basin with nutrient-consuming aquatic plants. With large depths and a pond volume limited in Germany to 100 cubic meters, we get 2 small swimming lanes in the base area, because we want to do 5 up to 10 swimming moves in a row. Further technology except for a skimmer, the associated low voltage pond pump and a dirty water pump for suctioning the mud at the bottom of the pond are not involved. Version 2 of a swimming pond. These ponds have an ideal depth of 1.35 to 2 meters. They have a width of 4.5 to 7 meters and a length up to 14 meters. The pelvic edges do not fall vertically but obliquely. There is at least one not too deep step around the pond basin of about 50 to 70 centimeters. This creates safety for unsafe swimmers when we get closer to the middle of the pond with broomston the pool without having to swim. Another advantage is to be able to supply the plants better on the water side with plant modes. surrounding water plant ditches. A second separate basin represents the plant filter trench on one side of the pond. It takes over the biological, for example chemical-free cleaning performance of the pond water. In order to prevent the mud from being extracted from the ground, or only once a year, suction gutters at the bottom of the pond and their suction pipes have been poured into the concrete works during the construction of the pond. These are no longer visible. This means that the pond muck is continuously extracted via the pond pumps. A skimmer is also connected to these pumps. The pumps should be controllable and sufficiently dimensioned for the line cross sections of the suction lines mentioned. Variance of water flow. As a rule, there are at least two systems in a filter chain for water flow. Here, only the sequences are reversed sometimes. Version 1 of a filter chain. One filter chain is swimming pond, then the water flows to the plant filter trench, then to the mechanical filter, then to the pond pump for the circulation, and then back to the swimming pond. This version is declared now. The muddy water from the suction pipe at the bottom of the pond, the dirty surface water of the skimmer, is sucked in by means of the pond pump for cleaning on the longitudinal side of the plant filter trench. The pond pipe is located at the opposite clean end of this trench, so that the pump is not destroyed prematurely by the dirt cargo. There, the biologically purified pond water also runs back into the swimming pond. At this end and in front of the pond pump, there could also be an additional mechanical pond filter. The disadvantage of this filter chain is that the filter trench accumulates with nutrients faster and needs to be harvested more often. Version 2 of a filter chain. The filter chain is swimming pond, then the water flows to the mechanical filter, then to the pond pump, then to the plant filter trench, and then back to the swimming pond. Now this version 2 is explained. The muck water from the suction pipes at the bottom of the pond and the dirty surface water of the skimmer is extracted directly to the mechanical filter by means of the pond pump. The pond water, which is mechanically filtered out by suspended particles, is pumped through the pond pump to a longitudinal side of the plant filter trench for the subsequent biological cleaning. On the opposite longitudinal side, there is an overflow through which the purified pond water flows back into the swimming pond. The difference between a gravity system or a pumped system. Suction lines in a gravity system. Pond pumps in 12-volt or conventional waterproof 230-volt technology are optimized for low power consumption and continuous running performance. For this, we have the disadvantage that they are hardly suitable for height differences, such as, for example, waterfalls with significant performance drops from 1.5 meters height difference. Pond pumps have a suction and a pressure side. On the pressure side, they like to weaken. Therefore, it is possible to optimize their performance by not having to cope with any height differences in all suction and pressure lines if all pipes are below the water level of the entire pond system. Most ponds, however, are the opposite, so-called pumped systems, because their mechanical filters are above the water line, namely next to the pump and thus outside the pond. Another positive aspect of the gravity system is that the pipe's cross-sections are often larger than with pumped water circuits, because they are looking for maximum water flow and thus a performance optimization of the pond pumps. This is ensured by pipe cross-sections from 100 to 200 millimeters. Due to the lack of pressure behavior of any pond pump, an additional pipe on the pressure side will be added to optimize the system. State-of-the-art pump technology. Today, only 12-volt pumps, which are in the pond, underwater, adjustable 230-volt pond pumps, and air lifts are eligible in continuous operation. A 10,000-liter pond pump per hour should not exceed 220 watts per hour today. There are adjustable 220,000-liter pumps that consume 150 up to 160 watts per hour under full load, yet regulated down to approximately 10,000 liters, but well below 100 watts. Therefore, adjustable pond pumps are more economical in continuous operation when they are regulated down. The modern pond pump is called airlift. However, the most economical variant in gravity technology is an airlift. These pumps come from the koi pond industry and have always been used in mini-formed aquariums. They are to be built from do-it-yourself materials themselves, except for the air membrane. They can be operated with up to 1 watt per pumped 1,000 liters per hour. My airlift, for example, carries about 40,000 up to 45,000 liters per hour with 25 to 120 watts per hour. It is driven by 2 air compressors of 100 liters per hour. The principle is simply explained. Pond water flows into 125 to 200 millimeter wide standpipes from 150 to 250 water column height. At the bottom of the standpipe, there is an air rise over the rising air beads within the standpipe. This means that large amounts of water can be recirculated via sufficiently dimensioned pipes in the pond water circuit, which would not be possible with a pond pump system at all, or only with a significantly higher power consumption and larger sized pumps. Another positive effect is that there are no power lines in the pond, as is the case with conventional pond pumps, which makes this particularly suitable for swimming ponds. Furthermore, they enrich the pond water with atmospheric oxygen by their design. Biological and mechanical filter technology. The plant filter trench or the biological filter technique. The plant filter trench should be between 30 up to 120 centimeters deep and provide at least 2 or 3 depths for the aquatic plants, underwater plants, and nutrient-consuming reeds. Remove nitrogen and phosphates from the nutrient-rich water and significantly reduce algae growth. In the area This trench at the edge of the swimming pool should make up to 30% of the swimming area. The less filter technology is used, the larger it has to be dimensioned. The aquatic plants have the following tasks. First, they provide a huge surface underwater for bacteria, the so-called destructors. These decompile biomass into their basic components, including nitrogen and phosphate. Second, these plants in turn use these substances to convert this biomass into plant growth. Aquatic plants are therefore producers. Third, it mainly converts algae biomass into plant biomass. Fourth, at the end of the year, this can be removed from the plant filter trench. It results in a fantastic compost. A prerequisite for the use of these aquatic plants is a sufficient water circulation. In order to simplify the cleaning function, this should be done permanently from spring to autumn. Even in nature, crystal clear waters are often recirculated. Additional filter technology. UVC lamps kill algae. But they also kill any other way of life, forms of life. This aggressive radiation causes algae to clump together so that they can be better filtered out. My opinion is that we should do without this technique, because aquatic organisms living in the water and necessary for water purification are also dying in this process. The skimmer. It is important to include a skimmer that sucks the falling nutrients from the water surface before they sink to the ground and form nutrient-rich soil mud. The floor extraction. In order to avoid having to extract the ground too often with a dirty water pump, a floor drain can be installed every 100 to 50 centimeters wide. Mechanical filter technology. If the water quickly gets warm in summer due to little shade, a lot of dirt lands from the air in the pond or they swim with fish. Then we often need additional filtering technology. There are drum filters and slit sieves that, similar to the principle of a washing machine, carry dirty pond water over a sieve or drum, which have openings so small that the suspended particles are filtered out. A rinsing device regularly cleans the drum or sieves fully automatically. Split sieves are more suitable for a large water flow rate of 35 up to 60,000 liters per hour. Drum filters are available in different sizes and are sufficient up to 50,000 liters for normal use.